This is section 8.7 on graphing linear inequalities. It's pretty much just like graphing lines with a couple extra steps. So the first thing you want to do is solve for y, keeping it to the left. So you want to put your equation in y equals mx plus b form, because that's the easiest way to graph. So you want to isolate your y value, y variable, excuse me. And then you want to graph your line using slope-intercept form. That's the easiest way to graph. If there's a line underneath the inequality, you use a solid line to make your graph. If there is no line underneath the inequality, you use a dashed line. So a dashed line just looks like a broken line, like on the road when you change lanes, a broken line. So once you've made a solid or dashed line across the grid, it kind of cuts the grid in half diagonally. So you're going to then shade the appropriate space. You are going to want a colored pencil for this, or you can use your own just kind of side of your pencil, but a colored pencil helps it stand out along with a ruler to do the graphing. So shading the appropriate space, I just think if it's greater than, if y is greater than the expression, you shade above it, and if it's less than, you shade below. That's kind of a generic rule. Students can't always see that as clearly. Your textbook talks about a test point technique. That is the more mathematical way to do this. If you want to see that procedure, it's on page 466 of your textbook. But I'll show you my technique. It works. It's a little bit more abstract, but it does work. But if that's not really clicking for you, certainly turn to your textbook on page 466. Alright, so let's look at this first example. We have x plus y is less than 3. And the first thing we want to do is solve for y. So we're going to move the x to the other side, and we get y is less than negative x plus 3. Now it's in graphing form, or y equals form. My slope is negative 1 over 1, because there's 1 in front of this x. And we can always put it over 1, just like we did back in section 8.3. And then my y-intercept is 0, 3. So I'm going to start this graph at 0, 3. I'm going to go down a square and to the right, down to the right, down to the right, make several good points. Line up my ruler along my points. But instead of just automatically connecting it with a straight solid line, I'm going to look here. If there's no line underneath, instead of a solid line, I'm going to make a dashed line. So along my ruler, I'm going to make a broken line again, just like you see on the road between lanes, a broken line. You want to go all the way across your grid until it's completely cut diagonally. So it cuts your grid in half. And at this point, you really don't need to worry about the actual values on the axes. Just think of this diagonal cutting this square into two pieces. The top triangle is above the line, kind of on the top side of the line, and the bottom triangle shape here is underneath the line. So this is the above space, and this is the below space. Again, it's kind of abstract. You just kind of have to look at it. Another way to look at it is with a seesaw. If you know what that is, a little kid's seesaw, where two little kids will sit. I'm not the best artist. Two kids will sit on a seesaw and it will go up and down. So if you think of this as a seesaw, the kids will sit on the top of the seesaw, and then you have underneath the seesaw. So if that analogy kind of helps to see above and below. Once you've got it split between above and below, you look at your inequality once it's solved for y. So this is the one I want to look at to make my decision. Not the original, because the original takes some adjusting. You always want to have it in y equals form or slope-intercept form so that you can compare y to the rest of the expression. This symbol is less than. So it's saying y is less than the expression, so we're going to shade below the line. And every single point in the shaded region, which is there's an infinite amount of points below the line, every single ordered pair below that line makes this expression true. So any ordered pair you pick makes a true expression. So your answer is actually the graph. There is no other way to answer this besides shading the graph. On your homework, you'll pick a solid or a dashed line, you'll graph, and then you'll have a little paint bucket to shade below or above. And the paint bucket will determine your actual solution region. So again, any ordered pair in this set, any ordered pair down here, will make this expression true. So let's try that again. With example 2, I want to solve for y. If negative y is less than or equal to negative 2x plus 6, in order to solve for y, I'm going to have to divide by negative 1. So I have y is less than or equal to positive 2x minus 6. Oops. I knew that was going to happen. So when you divide by a negative, back from chapter 2, remember, you have to switch the sign. So when you divide by a negative, you might want to make another note of that. It pops up randomly, so you have to make sure you remember. Divide by a negative, you got to turn that sign. And that's why it's really important to solve for y before you put it onto the graph. So we learned how to graph from standard form, but for these we want to graph from y equals form. Alright, so let's graph that. We're going to start at negative 6, and my slope is 2, and if you want to put this over 1, so you can really see it, we're going to go from negative 6, we're going to go up 2 squares, to the right 1 square, up 2, to the right, up 2, to the right. You just keep going. I like to go pretty far across my grid so I can really see my pattern. Then we're going to look back here. We see a line underneath the inequality, so we're going to connect these with a solid line all the way across the grid because we're going to cut the grid into 2 parts. It's a very steep seesaw, but if we think of it as a seesaw, this would be above, this whole space would be above the line, and this would be below. So you really have to be able to see that for my little technique to work. If that is just not clicking for you, again, turn to your textbook and see the other technique, and it might work better for you. So above and below. We want to look at the y equals or y set y isolated inequality to make our decision. This is greater than, and so we're going to shade above the line. So every single point that's in this region and beyond, because this is just a 10 by 10 grid that could get even bigger, everything here is a valid solution point. So I just have a few more of these. If you'd like to try them on your own, you're more than welcome to. There's a couple special cases at the end, but I'll just keep working through these. They're not too difficult, but they do take a little bit of time. So this one says y is greater than or equal to x plus 2. It's already in graphing form, so I'm going to start at positive 2. My slope's going to be 1 over 1, so up 1, right 1. A few times till you really see the pattern. So again, y-intercept is here. Slope is the coefficient on x, which is 1 over 1. So you should be pretty good at graphing slope-intercept form. There is a line underneath, so we'll connect these with a solid line all the way across my grid. It splits the grid into 2 parts. If you think of this like a seesaw, this would be above the line and below the line. It's already in graphing form, so it's greater than, so we're going to shade above the line. And again, the shading is what is truly your answer. It's not the line itself, but it's the shading that tells you all the possible values for x and y that make the inequality true. Alright, let's look at example 4. Again, already in graphing form, y is greater than negative x minus 3. So my y-intercept is negative 3. Negative x would be a slope of negative 1 over 1. So I'm going to go down 1, right 1, down 1, right 1, down 1, right 1 a few times. There is no line underneath, so I'm going to connect these points with a broken line or dashed line, not including these actual values here. all the way across. It splits the grid into two halves. This would be above, this would be below, and then we'll look at our inequality. This is greater than, so we're going to shade above the line. So all the values, all the ordered pairs above that line, all the way up to the line but not quite touching it. That's why it's dashed. Every single ordered pair in this region is a valid solution. Let's look at example 5. Back to standard form, we're going to have to solve for y on this one. So I'm going to move 2x to the other side. That gives me 5y is less than or equal to negative 2x plus 10. Divide by 5. It gives me y. Now we divided, but it was a positive, so we're safe. Y is less than or equal to negative 2/5 x plus 2. So it's very important to get it into graphing form, into slope-intercept form, so we can see our inequality clearly. So we're going to start at positive 2. This slope is down to right 5. We always put the negative, or I always put the negative on the top. You can put it at the bottom, but the students get a little confused. I always think of it as negative 2 over positive 5. Just makes it easier for me. So from here I'm going to go down 2 and to the right 5, down 2 to the right 5. Just a couple good points so we can see our pattern. It's a line underneath, so we're going to connect with a solid line all the way across the grid. It splits it into two halves, so this is above and below. And we're going to look at the inequality from graphing form. It's less than or equal to, so we're going to shade below. Every ordered pair in this shaded region is a solution. So again, it's the shading that really is the answer. Alright, I think I have a few more examples here. You can pause again at any time and try them on your own. Let's look at example 6. We're going to move that x to the other side. We have negative 2y is greater than negative x minus 4. Divide everybody by negative 2. Careful with our signs here. Because we divided by a negative, and again you might want to make a special note. Anytime you divide by a negative, you got to turn that sign. So I'm going to turn it the other way. It was greater than, now it's less than. This is a 1, so negative 1 over negative 2 makes positive 1/2 x. Negative 4 over negative 2 makes positive 2. I know that looks a little strange. So now it becomes y is less than 1/2 x plus 2. So we're going to start at positive 2. 1/2 is up 1 right 2. Up 1 right 2. Up 1 right 2. A few times. We're going to connect them with a dashed line because there is no line under the inequality. So we used a dashed line for this one. And then it breaks it into two halves. This is above. This is below. And it's a less than. Again, you always have to use the graphing form to make this decision. If you use a test point, you can use any equation, but if you're going to use the above and below technique, you've got to have it in graphing form first. So it's less than, so we're going to shade below. Every ordered pair in this region is a valid solution. Alright, the last couple are a little special. I'm always save the special cases till the end. So this says y is less than or equal to 5. So let's remember how to graph. Let's think back. I think this was in section 8.3, how to graph y equals, not 3, I'm sorry, 5. So we usually just go to 5, put a point, and students just stop. But remember, it's every single point that has a y value of 5. So it's just every single point. Same rules apply. Y is less than or equal to 5. There's a line underneath. So we're going to connect it with a solid line all the way across. This more clearly cuts our graph in half, and it's easier to see above and below. And it's less than or equal to, so we're going to shade everywhere below that line. Every ordered pair below that line is a valid solution. Every point below it. Same idea with example 8. We have x is greater than -3. Think back of how to graph x equals -3. A lot of students will just put a point here, but it's actually every single point where x equals -3. So I always like to put a few to remind me of that. This time we're going to connect it with a dashed line. So make sure to make it nice and clear. Again, on your homework it'll be clear from the broken line. And above and below is a little different here. On the x-axis, remember, this is positive infinity and this is negative infinity. So the right-hand side is above, the left-hand side is below, just based on the number line and how that works. So this says greater than -3, so I'm going to shade above the line. So those can be a little tricky, but it's still not too bad. And that's graphing inequalities. Again, on your homework, you'll graph the line, you'll choose solid or dashed, and you'll use a little paint bucket to fill in whichever half is appropriate based on the inequality.